Hi folks, I'm going to go through in the next few videos some of the questions that we've had in our assessments. Okay, so we'll start with Unit 5 Quiz 1 and determining whether something's a function and their domain and range. So here, if we look in numbers 1 and 2, neither of these are functions. So number 1, we see that for x equals 1, there's multiple y values. So that makes that not a function. And then here, number 2, we notice that for the same input of 0, we have two different outputs, so that's not a function either. Okay, whereas here, even though this continues on, we can see pretty clearly, made up of two lines, that for any input, there'll only be one output. Okay, so this is a function. Now, for domain and range, I want to talk about how we'll give that answer. So here we've got a finite number of ordered pairs that are part of our function. Same thing here. So in a case like this, the easiest thing to do is to just list the domain and range values, whereas in number 3 there's infinitely many ordered pairs, because between, even if I look at these nice points, there's infinitely many points in between, so there's no way to list everything. So that's when we're going to use our inequality notation. Okay, so here I would just list the domain as -4, -3, -2, -1, 0, 1, 2, 3, 4. Okay, and then for the range, I see that that goes from -3 to +2. So again, can just list all those numbers. Okay, same thing here. I can list them. So we have our domain is 0, 3, 5. Now 0 appears again, so there's no point in repeating it. It's already indicated as part of the domain. And then for the range, we've got 4, 5, -2, 1. Okay, now you could certainly give this in order, but I'll accept either answer. Okay, whereas here for the domain and range, there's no way to make a list. So that's when we describe the domain. Okay, so again, don't forget your curly brackets to represent that it's a set. Okay, in this case here it's domain values. So here the x-axis, so x can be any real number, and in this case here, there's no conditions on what x can be. Since this is continuing on in both directions, x can be any real number. So that's it, done. Okay, whereas for the range, we see that there's limitations on the range. It could be any real number, but nothing greater than 3. Okay, so here we would write y can be any real number. Since there's a condition, we use our such that, and here y could be any number less than or equal to 3. Okay, now while we're at it, since I was going to do number 2 on this sheet, might as well do it right away. Okay, here we have a function defined by an equation. So in the previous example, it was defined by either a graph or a set of ordered pairs. Here it's defined by an equation, and we can determine particular y values. So here I'll start, I won't do A, I'll do B here. What this means is, what is the y value of the function f when the input, or the x value, is -2? Okay, so all we have to do is wherever we see an x in our equation, we're now going to replace that by the input of -2. So 3 times -2 squared. Make sure you put your input in brackets so that you're correctly calculating the final value, minus 2 times, again, -2 in brackets, and then minus 3. That part doesn't depend on x. And then from there, you can either stick it in your calculator or start to calculate it. So -2 squared is +4. Okay, here -2 times -2, again, +4, minus 3, and so here you've got 12 minus 4, 12 plus 4 is 16, minus 3 is 13. Okay, whereas in C, the input itself has a variable in it. Okay, but we're following the exact same pattern. Whatever our input is, that's what's going to be replaced wherever I see an x in the equation. So here I have an x that's going to be replaced by the input of -2x squared. And then what am I doing to that input? I'm squaring it. Okay, then minus 2 times my input, -2x squared, and then minus 3. Okay, so here, this point is just about being careful about the algebra. So here, I can distribute the exponent. So negative 2 squared, this whole thing is being squared, so that's going to become positive 4. X squared squared, x to the 4th. Okay, and then here, negative 2 times negative 2, so plus 4 x squared, and then minus 3. And then lastly, finish that off, 12x to the 4 plus 4x squared minus 3. And since there's no like terms, that's as simple as it gets. Okay, that's it for these two questions.